We are now going to be learning how to apply the knowledge of distance between 2 points in solving. Okay, find the distance between points P 5, 4 and the points common to the lines this and this. 2x minus y equal to 4 and x plus y equal to 2. Okay, so this will be applying the knowledge we knew before. Now, the common point between two lines is where the lines intersect. And to find the coordinates of the points where the lines intersect, so this is like solving simultaneous equations. The answer to simultaneous linear equations is the coordinate of the point where the two lines meet. Right? Good. So all we are just going to be doing is that we're going to solve these two equations simultaneously. The answer for x and y is the coordinate of the points that we need to solve this. So what we are doing here is to now invite a previous knowledge, which is coordinates of solution of two linear equations. Okay, let me use elimination method to solve this, or do we use substitution? Let's use substitution. So we have this equation 2x minus y equal to 4. We call this equation 1. We have x plus y equal to 2. We call this equation 2. Then from equation 2, I can easily get a substitution, or even from equation 1. From equation 1, let me have y as the subject of the formula, so I can send y to here and then 4 to this other side. So we now have that 2x minus 4 is equal to y. So I'm going to substitute this for y in equation 2. So we have to substitute into equation 2, we have that x plus, instead of having y, we are now going to have this 2x minus 4 is equal to 2. Remember, right? X plus 2x is equal to 3x minus 4 equal to 2. We collect like terms. We have that 3x minus is equal to 2 plus 4. So we now have that 3x is equal to 6, and then we divide both sides by 3. We have that x is equal to 2. So if x is equal to 2, then from this equation, we are going to find that y is now equal to 2. Instead of x, we have 2 minus 4. Right? We are substituting again this value of x into this. Y is equal to 2 times 2 is 4. And then 4 minus 4 is equal to 0. Therefore, x equal to 2 and y equal to 0 is the common point of those lines. That is where the lines meet each other. So, remember our question says that we should find the distance between points P and the common points to the lines this and this. Now we went all through that route to solve this simultaneous equation. But now we have arrived at our point. So between the points, so the first point is 5. So this is point P, right? And this other point, 2, 0, that is representing the solution to that equation. So this now becomes our coordinate points that we need to solve to get what's the distance between this point P and this point where the two lines given to us, equations of the two lines given to us meet. We have this as x1, y1, x2, y2. Okay, we now have that the distance between the two coordinate points is x2 minus x1 squared plus y2 minus y1 squared, the square root of all this. The distance is equal to x2 is 2 minus x1 is 5 squared plus y2 is 0 minus y1 is 4 squared. So that distance is equal to 2 minus 5 is minus 3 squared plus 0 minus 4 is minus 4 squared. Okay, so at this point, we now have that minus 3 squared is 9, minus 4 squared is 16, 9 plus 16, that is 25. The square root of 25 is 5. So the distance between those 2 points is actually 5. I know we went a long way, but just patience and the application of what you already know. Now for this next one, we have to show that this point 2, 3 and this point minus 3, 2 and these points are the vertices of an isosceles triangle. Now, what is an isosceles triangle? An isosceles triangle is a triangle that has 2 equal sides. So once we have found, now they are asking us to prove that, let's say P, Q, and R, for example, are the vertices. They're asking us to prove that these points for P is 2, 3, for R is 2, minus 7, and for Q minus 3, minus 2. To prove that these are the points. So, of course, we don't know whether it's these 2 points, these 2 lines that are equal. We don't know. This is just a sketch. It will guide us in solving. So, for us to prove that, we have to find out that the distance between 2 of the points, that is a pair of the points, they are equal, and then the other one is a different value altogether. So, what we are going to do is we are going to find the length of the line PQ. The length of the line, so we found PQ, PR, and then PQ, PR, and then QR as the remaining line. Okay, 2 of them should be equal. Okay, so when we talk about PQ, that means this is the first values, these are the second values. So this minus this and this minus this, that is what we work with. So we have for the x2 minus x1, so minus 3 minus 2 squared plus y2 minus y1 minus 2 minus 3 squared. Should have given a space in between. Minus 3 minus 2 is minus 5 squared. Minus 2 minus 3, that's another minus 5 squared. So we have that this is equal to 25, right? Plus 25 giving us 50. So this is 50. Okay, for PR, we have PR. Now, what we need is that this is the second value. So this is our x1, this is our x2. So all this minus this. We have 2 minus 2. Right? Squared plus minus 7 minus 3 squared and then we now have 2 minus 2, that is 0, minus 7 minus 3, that is minus 10, minus 10 squared. So this is already 0, minus 10 squared is 100. So the length of this line, PR, is 100. Okay, so the next one we are going to find should be either equal to 50 or equal to 100. And this will prove that these points are the vertices of an isosceles triangle. So for QR, right? So since we said QR, that means this is the first values, these are the second values. So this minus this. If this will confuse you, always write them out as these are the first points, these are second points, so you can name your x1, y1, x2, y2. But if you can understand with the diagram, fine. But if it will confuse you, use the space you have in your workspace. Okay, for this we have the x values, that is 2 minus minus 3, plus the y values, minus 7 minus minus 2. Okay, 2 minus minus 3 is like saying 2 plus 3, so that's giving us 5. Remember, it should still be squared. Minus 7 minus minus 2. So this minus minus gives us plus. Minus 7 plus 2, that is a minus 5 squared. So this is 25. This is also 25. Please, this is the square root of, I've forgotten that there is square root at the end of the whole day. So this is giving us 50 again, the square root of 50. So the square root of 100 we know is 10, and then this is 5 root 2. But we can see that these two are already equal. So we have proven that these points are the vertices of an isosceles triangle with PQ and QR being equal. So PQ and QR, wow, it was a right guess, being equal, but this side is actually longer. But that is just it for applications. And if we were asked to find the perimeter of the triangle, we always know what to do. When we find the length of all the sides, perimeter is just to add up the length of the sides. We would have just calculated what these values are and then added them up. That would have been the perimeter of the triangle. So these are some of the applications of distance between 2 points that's giving us a straight line, the shortest distance between 2 points.